Hello, my name is Shahaf, and I'm part of Classiq's Quantum Applications team. In this video, we are going to talk about use cases in the supply chain and logistics domain, a vertical that becomes substantial when it comes to quantum computing technologies. Quantum computing, being a new groundbreaking technology that can solve many mathematical problems that classical supercomputers cannot solve in a timely manner, becomes an important factor to solve some of the supply chain industry most emerging problems. In this video, we are about to review some of the supply chain industry problems and how Classiq can leverage the power of quantum computers to solve them. Many retailers and transportation companies have already started to explore different applications that will help them increase efficiency. Names such as vehicle routing problems, inventory management, and task scheduling are common and widespread in the industry. We anticipate that other delivery, transportation, and retail companies will follow the big companies and improve their quantum inventory in the short and medium terms. Classiq is a software platform for developing quantum code, and its main goal is to automate the generation of optimized quantum circuits. Some of them are relevant to solve the supply chain industry challenges. As of April 2020, Classiq is reaching its 4th anniversary. Classiq's headquarters is in Tel Aviv and has presence in Europe, North America, and Japan. We raised $63 million to date. So how to begin? Many of the challenges that the industry experts tackle are optimization problems. As such, modeling the problems as a minimum or maximum mathematical problems opens the doors for a variety of quantum algorithms that can solve many of these challenges in a more scalable approach. Let's say you want to plan the most efficient delivery path for a delivery services company, visiting a list of cities while minimizing time and distance. This scenario mirrors the essence of optimization problems, complex challenges that span logistics, supply chain, and beyond, requiring solutions that balance numerous variables to find the optimal outcome. The quantum approximate optimization algorithm, QAOA, represents a groundbreaking approach, leveraging quantum computing to address these optimization problems. With the anticipated development of the quantum hardware that will make it stronger and with fewer errors, aiming to surpass classical computing's limitations. At its core, QAOA employs a hybrid quantum classical mechanism. Through a sequence of quantum gates, the algorithm encodes the optimization problem and iteratively refines the search for the optimal solution. This process involves two key operations: the problem Hamiltonian, reflecting the problem's objective function, and the mixer Hamiltonian, guiding the exploration across the solution space. By adjusting these operations' parameters via classical optimization, QAOA converges towards the solution with the highest objective value, demonstrating a sophisticated blend of quantum and classical computing prowess. That means that every optimization problem that can be defined mathematically as a minimum or maximum problem can be solved using the QAOA algorithm. One of the most emerging problems in the industry is the facility location problem. The facility location problem is a common decision-making challenge that businesses face when they need to decide the best places to open new facilities, such as distribution centers, warehouses, or factories. The goal is to choose locations that minimize costs and maximize service to customers. In order to solve it, we can use the Classiq's QMod language and the QAOA algorithm described earlier. We will allocate the variables, initialize the states of the problem to get a wise guess of how the optimized solution looks like, and run several iterations until we get to the optimized solution. We can set constraints here on the right side of the screen. When we click Synthesize, the Classiq quantum software will generate a quantum circuit which we can execute on one of many quantum simulators and hardware providers. On the left side of the screen, we can see the characteristics of the circuit: its width, depth, gate count, and other characteristics. We can also create a circuit that is suitable for specific hardware. Eventually, we will get the solution of which facilities we should open and in at what cost. On the right, you can see the solution and how it looks like. On the left, you can see the convergence graph, the graph that indicates the result of the cost function, which, as far as the algorithm goes, converging into the optimized solution. Similar problems, such as electric grid optimization, as well as variations of radio access network optimization problems, can be solved in a very similar way. Let's see how we use QMod in Python. QAOA can solve many other problems relevant for logistics. In this example, we modeled the task scheduling problem. So given a number of resources, workers who will perform the job and time slots, and given a set of constraints, assumptions, and dependencies, we will use the QMod language to identify the right order of task. We have a list of helper functions and definition of the problem using the QMod language. This is the result of the task scheduling quantum circuit, based on the same QAOA approach. You can see the layers clearly. This circuit can be executed on all available quantum hardware and simulators, or being exported to a quantum assembly format. The purpose of this video is to demonstrate how Classiq's quantum software can help solving some of the industry's main challenges. If you are an innovative professional from the supply chain industry and want to be at the front of the technological developments, reach out to Classiq to hear more about the future of solving problems for companies like yours. Thank you for being with Classiq today.